once again to Ask IITians. So as per in the previous lectures we have discussed a complete chapter related to kinetic theory of gases, where we have discussed about the law of equipartition of energy, what are translational kinetic energy, what is total internal energy, what are the degrees of freedom. Now this is the best time where you could take care of all the knowledge that you have got and you can try using this over to the questions. So I have compiled here certain questions from previous year IIT JEE exams. Let us try out all these questions one by one so that you people get confidence over whatever you have learned. So now let us begin up with the session. Now students, let us begin with the previous year IIT JEE questions. So let us begin with the very first question that has been asked with reference to the kinetic theory of gases in the chapter. So the first question that I am going to consider here is: a rigid tank contains 35 kilograms of nitrogen at 6 atm. That means you have been given the gaseous species, and that gaseous species is contained in a rigid tank at a pressure of 6 atmosphere, and the total mass of nitrogen has been given to be 35 kilograms. Now, sufficient quantity of oxygen is supplied to increase the pressure to 9 atmosphere. That means now he is mixing another kind of gas, oxygen gas is being mixed to the already existing nitrogen in the container, so that the total pressure now goes over to 9 atmosphere. While the temperature is remained to be constant. So the amount of oxygen supplied to the gas is. Now we need to find out after the 4 options what is the amount of oxygen that has been supplied in the above condition so as to keep the temperature at a constant value. So now let us begin up with the question. First of all, we know that if I am going to follow the ideal gas equation, I can very easily say that PV is equal to nRT. That means I can very easily say this thing also, that pressure is directly proportional to number of moles. So I can say from here is P1 by P2 will be nothing but N1 by N2. That means P1 over N1 is equal to P2 over N2. Now, if I ask you to substitute the values, I can say that N1 is nothing but 35 divided by 28 into 1000, which comes out to be 1250. So this is how I have obtained the value of number of moles of one particular gas, nitrogen. Now if I follow the same particular thing with respect to another gas, oxygen, I can say that, so I can very easily write N2 is nothing but 1250 over 6 into 9, which comes out to be 1250 into 3 by 2. So I can reduce this expression and it becomes 1875. So once I know the value as 1875, I can further move on and I can say that since N2 is nothing but the number of moles of nitrogen plus number of moles of oxygen, now this total is equal to 1875. So this is where we have used P1 over P2 is equal to N1 over N2. So using this expression, first of all you need to get what is the total number of moles of the gases which are present in the container. So now you know the number of moles of nitrogen plus the number of moles of oxygen is nothing but 1875. If I ask you to substitute the value as 1250 for the number of moles of nitrogen, you can get the number of moles of oxygen as 1875 minus 1250. So number of moles of oxygen comes out to be nearly 625 moles. Now if you know the number of moles, you can say that number of moles into the molar weight is nothing but the mass of the gaseous species which is present. That means now you have 625 moles into, so if you are going to multiply it with 32 grams per mole, this mole got cancelled and the value comes out to be 20 kilograms. So on solving this, you will get the value as 20 kilograms. Let's see if such value is given to us in the question. 5, 10, 40. So 20 kilograms, option number C is the correct option for this particular question. Now once we are done with question number 1, let us come over to question number 2. Here it says that when 2 grams of a gas are introduced into an evacuated flask which is kept at again 25 degrees Celsius, the pressure is found to be 1 atmosphere. So you know what is the pressure, you know what is the temperature, and you know what is the mass of the gas which is present in the container. Now if 3 grams of another gas are added to the same flask, the pressure becomes 1.5 atmosphere. So again he has done the same thing, that he is adding another particular gas in the same flask and the new pressure comes out to be 1.5 atm. The ratio of the molar weights of the two gases will be. So I'll ask you to proceed on the similar grounds as per whatever we did in the earlier question. So since you can write PV is equal to nRT, from here you can get P is directly proportional to N. So number of moles 1 will be given as 2 by molar mass and 2 will be given by 3 by molar mass. So P1 over P2 can be written as nothing but N1 over N1 plus N2. So now from here we know N1 plus N2 is nothing but 1.5 times of N1 because it has been given to us in the data points in the question. So now once we are done with here, I can simply say that N2 is nothing, N1 over 2. So now you have got the relationship between the number of moles of the two gaseous species. Now on knowing the relationship, we can just put the values in the equation. 3 over M2 can be written as 2 over M1 multiplied by 2. So I can say that M1 over M2 comes out to be 1 by 3. So the ratio M1 is to M2 can be written as 1 is to 3. Let's see if there is any such option. Yes. So option number A is the correct option for this question number 2. Having done with question number 2, it's the time that we should proceed over to question number 3. Question number 3 says, consider a gas at a temperature T. So there is a gaseous system which is given at a temperature T, occupying a volume V consisting of mixture of two gases. Again there are two different gases having Na and Nb number of atoms and the masses are given to be Ma and Mb respectively. So you have to give an expression for the total pressure which is exerted by the gas. Now how are we going to do such questions? To do such questions again we will be using for any ideal gas, PV is nothing but can be equated to nRT, where N is nothing but the number of moles of all the gases which are present inside the container. So N can be written as Na plus Nb divided by N. So this is what has been given to us in the question itself. So we can simply put up the values and I can say that P is equal to nRT over V. Now since you know total number of moles, since you know the volume, you can also say that P is Na plus Nb divided by N into R into T divided by V. So this was the N, the number of moles of all the gases which are given to us. Now since this is given to us, I can relate it to be Na plus Nb divided by V into RT divided by N. So I can also write it to be Na plus Nb by V. Now we know R by Na is nothing but equal to Kb, which is nothing but Boltzmann constant. So let me replace it as Kbt. Let's see if there is any particular option which has been given like this. Na plus Nb divided by V into Kbt. So yes, option number A is the correct option for such question. Now coming over to question number 4. It says that suppose now that Na is equal to Nb and the two atoms, so this question is just in continuation with the previous question, and that the different atoms combine at constant volume to form the molecules of mass Ma plus Mb. Once the temperature returns to its original value, what would be the ratio of pressure after the combination to the pressure before? So you need to find what is the ratio of these two pressure terms. Now, if you are going to find what is the ratio of these two pressure terms, let us proceed it the way we can. So we can say that a very simple fact, I'll be writing it over the board so that you can get to understand what I'm talking about. A very simple fact says that after getting combined, like when you are combining the two molecules to form a new molecule of a particular molar mass known as Ma plus Mb, the number of the moles become half in this case. See, what I'm going to say is that before combination, whatever was the number of moles, say let the number of moles N was equal to number of moles of A plus number of moles of B. Let's say this value was X. Now I am saying after combining. So once you have done the combination, the number of moles become half. So total number of moles of gaseous species, they become half. So if they become half, that means there will be x by 2. Now what I can say is that since the question doesn't end here, I need to move on, and I will simply say that at constant volume and temperature. Because specifically it has been mentioned to us that the temperature of the system and the volume of the system has to be kept as constant. So since we know that PV is equal to nRT, when V are taken to be constant, so pressure is directly proportional to N. Since N becomes half, earlier it was X, now it is becoming X by 2. So if earlier the pressure was P, now the pressure will become as P by 2. So the pressure will also become equal to half. Let's see if any such option is there given to us or not. So it's 1, 1 by 3, 1 by 2. Yes. So option number C is the correct option for this question number 4. Now having done question number 4, now it's the time that we should move over to question number 5, which says that CV and CP denotes the molar specific heat capacities. It should be heat capacities of the gas at constant volume and constant pressure respectively. Then CP minus CV is larger for a diatomic ideal gas than for a monoatomic ideal gas, or CP plus CV is larger for a diatomic ideal gas than for a monoatomic ideal gas. That means what do we need in this question is we need CP minus CV once for a diatomic gas, and then we also need it for monoatomic gas. Also for both these two gases we need the value CP plus CV. Then again he says CP by CV is larger for a diatomic gas than for a monoatomic gas, and CP multiplied by CV is larger for diatomic gas and then for a monoatomic. So students, to do any such question of this particular type, what I will ask you to first of all write down the data points that are given to you, calculate the options for all the four options which are given, and finally find out which is the correct option and which are the wrong statements. So let's begin up with the answer. I will simply say that CV is nothing but F by 2 into RT. Now what is this F? And we know that CP can be written as F plus 2 divided by 2 into RT. So once we should keep this fact and another fact in mind. Now for a diatomic gas, I can say F value as 5. So the number of degrees of freedom for any particular diatomic gas is equal to 5. Now once we know this thing, I can write CV as 5 by 2 RT. So once you know CV, you can also write CP as 5 plus 2 by 2 RT. That means nothing but 7 by 2 RT. Now this was for a diatomic gas. Let us do it for a monoatomic gas now. For any particular monoatomic gas, as per we had discussion in the earlier lectures, F is 3. So CV is nothing but 3 by 2 RT, and CP is nothing but 3 by 2 plus 2, that is 3 plus 2 by 2 RT, which is nothing but equal to 5 by 2 RT. So once you know the value of CP and CV, let us calculate it for all the four cases. First of all, let me begin with case number 1. It says CP minus CV you need to find. So let us find out what is the value of CP minus CV. It says this is equal to R. Let us find it out. So we know, right, CP minus CV is equal to R whether the gas is a monoatomic gas or the gas is diatomic gas. So the first option which has been given to me is the wrong option. Now let us come over to option number B that is given to us. Let us find CP minus CV for a diatomic gas first. For any particular diatomic gas, I need to find the value of CP minus CV for a diatomic gas, that is 7 by 2. So CP plus CV, if I need to find 7 by 2 plus 5 by 2 RT, which is nothing but 6 RT. This is for diatomic gas. And if I ask you to find CP plus CV for a monoatomic gas, it is 3 by 2 RT plus 5 by 2 RT. So this comes out to be 4 RT. That means CP plus CV for a diatomic gas is greater than CP plus CV for a monoatomic gas, and hence option number B is correct. Let's come over to option number C. For such questions, do check out all the four options, because it's not like you got option number B and you will mark the answer as option number B. So you should get the tendency of moving ahead in the question step by step. Coming over to option number C, we need to find Cp by Cv. Let us first do it for a diatomic gas. So this is 7 by 2 RT divided by 5 by 2 RT. 7 by 5, the value comes out to be 1 by 4, and for a monoatomic gas, it comes out to be 5 by 2 RT divided by 3 by 2 RT, so the value comes out to be 5 over 3, 1.6. Again, if you compare the option which is given, option number C will be found to be false. Come over to option number D. You need to find Cp dot Cv for a diatomic gas first. So 7 by 2 multiplied by 5 by 2 RT square, which comes out to be 35 by 4 RT square. And for a monoatomic gas, if you do it 5 by 2 into 3 by 2 RT square, it comes out to be just 15 over 4 RT square. So again, if you compare the value, you will find option number D is also correct. So for this particular option, I'll say option number B and option number D are the correct options. So students, these were all the questions which have been asked in the previous year IIT exams. I suppose these questions were quite helpful to you. Students, here at Ask IITians, we provide you a very good opportunity where you can ask your doubts also if you have any doubt regarding any topic. For that, you first of all have to go on to www.askiitians.com website. If you open the page, you will find a topic as Ask a Question. So you can click at that link, Ask a Question. At the right hand side, you will get something where you will have to first of all select a category. The different categories that will be available, like it will be, you can have physics, you can have a question from maths or chemistry. So suppose I select a question from chemistry, then here you can also attach the image of the question if you have in account. Else you can type your question here and finally click over to get an answer. As soon as you type something over to get an answer, you can ask the question from your respective teacher. So hope this also helps you out and your query will be solved. So students, this was all about the kinetic theory of gases. Let me try to refresh everything in one go. First of all, we discussed something about what are the different laws related to any ideal gas. I told you something about what do we mean by Charles' law. Then we had a discussion about something known as Boyle's law and Gay-Lussac's law. Then taking into consideration all the laws that we have discussed, we finally arrived to the ideal gas equation. Having done something about what do we mean by ideal gas equation, we try to move over to the properties of the kinetic theory of gases. I had told you certain assumptions which are taken for the kinetic theory of gases. After those assumptions, I tried to explain you the derivation for how to find out the pressure exerted by the ideal gas molecules on the walls of the container. Having done this thing, I told you how the energy is distributed among different molecules, like what do we mean by the total internal energy and how the energy was distributed as translational kinetic energy. Once we were done with this thing, we discussed something about what is law of equipartition of energy. And for the detailed knowledge about law of equipartition of energy, I told you something about what are the degrees of freedom. Then we tried to calculate the degrees of freedom for various kinds of molecules, for example, monoatomic molecules, diatomic and polyatomic molecules. Then, having discussed about complete chapter, we moved over to the different last year IIT JEE questions. Now, since once we have done with all the questions, I suppose this chapter is pretty much clear to you. So what you can do now is to refer to other questions which have been asked in the previous year exams so that you get more of confidence with this chapter. Now, so you can stay tuned with Ask IITians once again so as to get knowledge about other chapters, whether it is physics, chemistry or mathematics. So stay tuned with Ask IITians and hope I'll meet you again with some other chapters soon.